Hi everyone, this is YouTube channel Maths Insights. Thank you for joining with me. In this particular video, I am going to explain you what is meant by a progression and types of progressions. First, if you want to know the meaning, the definition of a progression, you have to know sequence, then how to find a particular term in a sequence, and what are the types of progressions. Everything will be discussed in this video. Shall we start? If you want to know what is meant by a progression, first you have to know what is meant by a sequence. I made a separate video on sequences, series and progression for your better understanding. Please watch that video, then it will become very clear. Before going to define what is meant by a progression, you have to know what is meant by a sequence. Sequence is nothing but arrangement of numbers based on a particular law, particular rule. But coming to progression, progression is also arrangement of numbers, but all the numbers are obtained by using a particular or explicit formula. To obtain a particular number in a sequence, we don't have a formula. But in case of progression, you will have a formula. That is the main difference between these two. This will become very clear if you take an example. See, if you take 2, 3, 5, 7, 11, 13 and so on. This is the arrangement of numbers. What are these? All of you know these are prime numbers. See, prime numbers are arranged according to a rule. There is a definition for a prime number. Basing on that we are arranging. If you want to get the next prime number, that is 17, we don't have a particular formula but a rule. That's why this is an example for a sequence. This will not have any formula. But coming to this, 3, 6, 9, 12 and so on. 3, 6, 9, 12. Then you know the next term, that is 15. How it is obtained? You have a formula, that is 2n plus 1. If you put n is equals to 1, then you will get the first term. 2 into 1 plus 1, that is 2 plus 1, that is equals to 3. If you want to fourth term, that is 9, put n is equals to 4. Okay, 2 into 4 plus 1, 2 4s are 8 plus 1, that is 9. In this manner, you will get a particular term by using a formula. That type of sequence is called progression. I am taking another example also. 5, 25, 125, 625, and so on. See, this is also having a formula if you want to find any particular term. That formula is 5 power n, where n represents the term number. If you want to first term, then put n is equals to 1, then you will get 5 power 1, which is equals to 5. If I want get fourth term, place n is equals to 4. So 5 power 4 is equals to 625. This is the definition of sequence and progression. Now we will go how many types of progressions are there, what are the definitions, everything will be discussed. Mainly there are 3 types of progressions. Those are arithmetic progression, shortly written as AP, and geometric progression, and written as shortly GP, harmonic progression, HP. We will discuss what is meant by arithmetic progression, what is meant by arithmetic mean, how to find a particular term in an arithmetic progression, and how to find sum of terms in an arithmetic progression. So this video is exclusively for arithmetic progression. In the coming next 3 videos, I will discuss geometric progression in one video, harmonic progression in the second video, and in the third video, the problems which are related based on all these progressions. Arithmetic progression is a progression in which, in the arrangement of numbers, except the first term, all other terms are obtained by adding or subtracting a fixed term. This will become very clear to you when I take an example. See, 2, 4, 6, 8, 10 and so on. As per my definition, except the first term, all other terms are obtained by adding or subtracting. I am taking this example with addition. 4 is obtained by doing plus 2. 6 is obtained by adding plus 2 to its previous term. And also 8 is obtained by adding plus 2 to its previous term. Similarly, 10 is obtained by adding plus 2 to its previous number. All these are called terms of the progression. Generally, terms are represented by using T1, T2, T3, T4 and so on, Tn. T1 means first term, T2 second term, T3, T4 third and fourth terms, and Tn is nth term. And coming to this one, this first is called first term of the progression, and you may represent it either with the T1 or A. So wherever A is there, that is to be treated as first term of the progression, arithmetic progression. Now you are adding a fixed term. That fixed term is called common difference. Okay, common difference. We will use the letter D to represent the common difference of the arithmetic progression. Now I will take another example. 25, 20, 15, 10, 5, 0, minus 5 and so on. This is also example for arithmetic progression. See, if you subtract 5 from 25, you will get 20, minus 5, 15, minus 5, 10 and so on. These two examples are for arithmetic progressions, and these two will have a particular formula to obtain a particular term. For this, 2n is the formula. If you replace n is equals to 1, you will get the first term, that is T1. T1 is equals to 2 into 1, that is equals to 2. If you want to fourth term, you have to replace n is equals to 4, therefore 2 into 4, that is 8. In this manner, by using a particular formula, you may obtain any particular number. Similarly, for this also you have formula, that is 30 minus 5n. We will come to know how to obtain these formulas to find the particular terms. If you replace n is equals to 1, then it will become 30 minus 5 into 1, which is called first term. So 30 minus 5 is 25. You are getting first term. If you want to get, suppose, a fifth term, I have to replace n is equals to 5, that will become T5. So 30 into 5 into 5, that is equals to 30 minus 25, which is equals to 5. So you may use different formulas for finding the particular terms of an arithmetic progression. Now I am taking another example to explain you very clearly the common difference first term and nth term. 3, 6, 9, 12 and so on. You know, this is called first term t1, and if you add plus 3 to this the first term, then you are getting 6, and if you are adding again 3 to 6, which is previous term, you are getting 9. Similarly, if you add plus 3 to 9, you will get 12. In this manner you will get next terms. Here you know the first term is a. Okay, if you want to get the second term, you have to add something to its previous term. If I want to get 6, I have to add plus 3 to its previous term 3. So you know this fixed addition is called common difference. I am adding common difference d. Similarly, if I want to get the next term 9, I have to add another d. So a plus 2d. Similarly, if you want to get next term a plus 3d, and so on. This is the way how to represent, how to assume terms of an arithmetic progression with first term a and common difference d. Now this is first one, this is second one, this is third term, this is fourth term, and so on. Then what is the formula for nth term? If you observe, this is the first term, so a plus 1 minus 1 into d. 1 minus 1 is nothing but 0, 0 into d, 0. So a plus 0, again you will get a. If you want to get second term, a plus 2 minus 1 into d. 2 minus 1 is nothing but 1, 1 into d is 1. If you want to get this one, so I may write it as a plus 3 minus 1 into d. So 2 can be written as 3 minus 1. Similarly, and so on. How to obtain this nth term? If you see, if your term is 1, then here 0. If your term is 2, then the coefficient of d is 1. If your term is t3, the coefficient of d is 2. That means 1 less than. The coefficient of d is 1 less than the term number. Here also a plus, okay, if you want to reduce 1, n minus 1, n minus 1 into d. Therefore, this is the formula for finding the nth term of the progression. What is the use of this formula? This formula is used to find any particular term of a progression. In any arithmetic progression, they will give you first 4 terms or 5 terms or 10 terms. They will ask you 100th term. Then that will become somewhat difficult, but not impossible. It will become difficult. At that time, you will know the nth term of the progression by substituting a and d values, and if you want 100th term, replace n is equals to 100. This will become very clear by taking an example. This is the example. Find the 25th term of an AP 4, 7, 10, 13 and so on. If you want to find 25th term, you have to find the formula for nth term. That will be very useful for finding any particular term of the arithmetic progression. You know the first term. First term is, you are representing it with a, therefore 4. Okay, and the common difference, that is equals to d. You know that is obtained the difference of any successive 2 terms. You may write it as t2 minus t1 or t3 minus t2 and so on, tn minus tn minus 1. So if you are writing third term, then you have to write second term, difference you are taking. So I am taking the first two, 7 minus 4, so the common difference will become 3. You know the formula for nth term, tn is equals to a plus n minus 1 into d, just we discussed that. Substitute the values of a and d in this formula. A value will become 4 plus n minus 1 into d value is 3. Okay, on simplification you will get 4 plus 3 into n, 3n minus 3, that is equals to 3n plus 1. This is the formula for finding nth term. Now what I want to find 25th term of this arithmetic progression. So I have to put n is equals to 5. N is equals to 25. Therefore T25, term number 25 is equals to 3 into 25 plus 1. 25 3 is 75. 75 plus 1, that is equals to 76. 76 is the 25th term of this arithmetic progression. Next is arithmetic mean. What is meant by arithmetic mean? How to insert different number of arithmetic means between given two numbers. Suppose I am taking a and b and I want to find arithmetic mean of these two. See, arithmetic mean is obtained by adding the terms and dividing with 2. This is called arithmetic mean of a and b. If I want to put 3 or 4 arithmetic means between two particular numbers, then how it will be? Say I am taking 3, 10. Then they will ask what is the arithmetic mean of these two numbers. You know 3 plus 10 by 2 is the arithmetic mean of a and b. Mean is nothing but central tendency. So to find the central tendency, there are different types of methods. This is one method. Okay. Now they will ask you different types of questions. Insert 4 arithmetic means between 3 and 20. Insert 3 AMs, shortly written as AMs, between 3 and 20. After inserting these arithmetic means between these two numbers, then that will become arithmetic progression. So you have to assume 3 arithmetic means between these two numbers. Then by using common difference first term, you will find d value, a value. Let x1 comma x2 comma x3 be the 3 AMs between 3 and 20. After inserting these arithmetic means, then that will become arithmetic progression. Therefore 3 comma x1 comma x2 comma x3 20 is an AP. Is it or not? So you know the first term. Therefore first term A is equals to 3. What is the last term? 1, 2, 3, 4, 5. Fifth term is fifth term. T5 is equals to 20. You know formula for finding fifth term, that is T5 is equals to a plus 4d. If you use the formula a plus n minus 1 into d, then that will become a plus 4d, which is equals to 20. Now I will replace a is equals to 3 in this result, that is 3 plus 4 into d, that is equals 20. In this case 4d is equals to 20 minus 3, which is equals to 17. Therefore d is equals to 17 by 4. You know d and a. Then the first arithmetic mean x1 is equals to, x1 is the second term in the arithmetic progression. Therefore second term means a plus d. You know a, that is 3 plus, and d 17 by 4, that is equals to 12 plus 17 by 4. I am taking LCM. 12 plus 17 will become 29, 29 by 4. Coming to the next AM, x2. x2 is 1, 2, 3, third term in the progression. Therefore a plus 2d, that is 3 plus 2 into 17 by 4. Okay, 2 ones are 2 twos are, that is equals to 3 plus 17 by 2, 6 plus 17 by 2 by taking LCM, that is 23 by 2. Next and last one is x3. x3 in the progression is fourth term, that is t4. You may write t4. t4 means a plus 3d. Okay, a plus 3d is equals to 3 plus 3 into 17 by 4. I am substituting the values of a and d, that is equals to 3 plus 51 by 4. So 12 plus 51 by 4, that is 63, 63 by 4. This is the third arithmetic mean. If you insert all this, then AP is equals to, therefore AP is equals to 3 comma, first one is 29 by 4 comma, second one is 23 by 2 comma, third one is 63 by 4 comma, finally what is this, 20. So in this manner we will insert whatever the number of arithmetic means between any two given numbers in the arithmetic progression. This is very important part in the arithmetic progression. How to find sum of terms in the given arithmetic progression. Suppose if they have given you 2 comma 4 comma 6 comma 8 and so on, these are 4 terms of AP. You can easily find sum of these 4 terms. 2 plus 4 6, 6 plus 6 12 plus 8 20. But if they are asking what is the sum of 100 terms of this arithmetic progression, then it will become very difficult. So you have a formula, you should have a formula for finding sum of any particular number of terms in an arithmetic progression. Generally nth term is represented with Tn. In the similar manner, sum of n terms is represented by using Sn. S is sum and n is number of terms. If you write S5, that is meaning that sum of first 5 terms of the arithmetic progression. S20 means sum of first, not in the middle. You have to start from the first, starting from the first term 20 terms. So how to find that? There are formula. Sn is equals to n by 2 into 2a plus n minus 1 into d. By using this formula, where Sn is sum of n terms, n is number of terms, a is first term, d is common difference of an arithmetic progression. If you know all those values and on substituting those values in this formula, you will get the sum of that particular number of terms. For example, I am taking in this case only, just I will find, you know, S4. S4 is nothing but sum of first 4 terms, and you know that is 20. By using this formula, I will get the same answer. Therefore S4 means n is equals to 4. 4 by 2 into 2 into a. A is the first term of the arithmetic progression, that is 2 plus n is again 4. You are going to find sum of first 4 terms of this arithmetic progression. 4 minus 1 into d. D is nothing but common difference. You may do t2 minus t1, t4 minus t3, whatever it may be. Now I am doing t4 minus t3. t4 here is 8. 8 minus 6, that is equals to 2. Substitute that 2 here. Okay, on cancelling, 2 ones are 2 twos are. Okay, this is 2 twos are 4 plus 4 minus 1 is 3. 3 twos are 6. So 4 plus 6 is 10. 2 into 10, that is 20. So if you want to find sum of any number of terms, this formula is useful. See, again you have to concentrate that this is infinite arithmetic progression, means there is no end for this. In any arithmetic progression, if you know the last term, then you have another formula to find the sum of terms of the progression. I am taking another example for this. This is the example 3, 8, 13, 18, 23. You know this is an arithmetic progression. If you want to check any progression, whether it is an AP or not, you have to do t2 minus t1, t3 minus t2 or t5 minus t4. In all these cases, you have to get the same value. Here 8 minus 3 is 5, 13 minus 8 is 5, 18 minus 13 is 5, 23 minus 18 is also 5. So you may decide that this is an example for arithmetic progression. Now I want to find sum of the terms in this arithmetic progression. If you observe, this is a finite arithmetic progression. Why? Because it is having only 5 terms, means finite number of terms. How to find? See, you know this is A. A is equals to 3, first term, and D, that is T2 minus T1, that is 8 minus 3, that is 5. And the last term is there. Last term is represented by using L, that is 23. If you know last term of any arithmetic progression, you have another formula for finding sum of these 5 terms. By using Sn, that is sum of n terms, n by 2 into 2a plus n minus 1 into d. You know this formula. In this, I will rewrite something. 2a may be written as a plus, okay, another a plus n minus 1 into d. Just I am rewriting it, nothing doing here. So n by 2 into a plus, this is nth term. You know the formula for nth term is a plus n minus 1 into d. So you may write tn. Tn is nothing but last term of the arithmetic progression. So I will replace tn with l, n by 2 into a plus l. This is the formula for finding sum of terms in an arithmetic progression if you know the last term and first term and number of terms. Now I will find S5, means sum of first 5 terms of this arithmetic progression. You know that n is equals to 5, therefore 5 by 2 into a plus l. A is 3 and l is last is 23. That is equals to 5 by 2 into 26, 3 plus 23. So 2 ones are 2 13s, 13 5s are 65. If you add all this, you will get 65. 3 plus 8 11, 11 plus 13 24, 24 plus 18 42, 42 plus 23 65. In this manner, you are able to find the sum of any particular number of terms in an AP if you know the first and last term. This is all about arithmetic progression. In the next video, I will solve some problems which are based on the concepts which we discussed in the video. If you like my video, kindly don't forget to subscribe it, share it, and encourage me to do more videos. We will meet in the next video. Until then, have a nice day. Thank you. Bye bye.